Hi, this is Jeff from the Ozark Mountains. Yep, in Missouri, USA. Today, we've got a couple of vintage cassette decks. This little Walkman style thing made by GE belonged to my dad. One of my sisters had this and it quit working on her. And I kind of spotted perhaps why without taking it apart. But we're going to see if we can't refurbish this and get it working again. This little guy, somebody sent to me. In part for fixing their Model 200, which will come up in another video. And it's just the cutest little thing from Radio Shack, but we'll have a closer look at both, and I'll show you how to go about measuring the belts so you get the right replacement belt. Let's get started. Thanks to PCBWay for sponsoring this episode. They offer an excellent quick-turn PCB prototyping service, which now has a free upgrade to the 150-160 temperature range. Ho, 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 it's that time of year. Check out PCBWay's 2022 PCBWay Christmas Big Sale. They've got lots of coupons and specials, so check it out and see what's in store for you. Okay, let's take a look at this GE mini recorder, recharge capable. And if we pop it open here, it's a little dirty inside. It looks like it has an actual erase head and that it's mono, but it looks like a pretty nice little unit till you flip it over. And yeah, this is a sure sign of corrosion. And if we pop this guy open, there is why. We've got some crusty batteries in there. I don't know how long these have been in here. By the looks of them, these may have been installed by my dad many years ago. So, I'll have to see how far this corrosion has spread through the machine. It looks rather nasty, and it's messed up the paint a little bit, but the springs aren't corroded away. And I think this did work up until last year. I think my sister might have used this adapter with it, which she sent along. And this looks like something my dad rigged up. I don't know what happened to the cover. The wires are getting a little frayed. And I think if we can get the recorder working, I'll find a new adapter in my stash and we'll send that back to her. Okay, now we have this little leatherette case housing the most cute little cassette deck. It is the CCR-82 computer cassette recorder. Here it is compared to the size of my hand, so you can tell how small it is. It has monitor in and out, so I guess you can hear it. Volume, pause, remote off, in, out. Interesting. Push your normal, eject, rewind, record. They put C-Save and C-Load on here. It's got a counter, a whole bevy of connectors there, 6 volt, aux input, remote, and microphone input. And this one has a clean battery compartment, so that's good. There is a label on the back of that guy. So, I'm just going to take these apart and measure up the belts. The belt settings are usually all shot, so there's not much point doing anything else. And the one that's corroded, we're going to have to take apart and examine anyhow. So, let's get to it. While waiting for the furnace to shut off, I took the opportunity to take a rag and some cleaner and clean up the outside and the back cover and stuff, just to make it a little more pleasant to work on. Get all that battery schmaltz all over your fingers. And I'll try to sneak these screws out of here. Oh, those are shorter. These two are plastic screws, and that one's a machine screw. As is that one. Okay. Is there something hiding from the inside? Oh, I see a screw right there. Okay. So how do we get this cover off like that? That was rather tricky, wasn't it? I hit a screw on the inside. It's a little flathead machine screw. I think that was the screw for that, or perhaps it wasn't. Nope, that was a screw for the door close switch. There's another screw right here. That is another one of those long plastic screws. So there's 3 long plastic. Oh, look at that. Now it just pops right off of there. There's some sort of alignment pin stuck to this part of the case. Oh, that was for the hand strap. Went through right there. Okay, so now we've got this open like this. We've got a built-in speaker. Our black wire is connected here where it says SP minus, the white wire where it says SP plus, and we can see our belts right away. So I'll turn the soldering iron on and we'll desolder these and have a look at the belts. So those aren't too terribly bad. Oh yeah, that one's really floppy loose. Yeah, they're both pretty loose. You can see how that's waggling there. Okay, so let me get the soldering iron turned on. Okay, curiosity got the better of me. You can see I have the power cord plugged in here. GE was nice enough. They marked on here the type, the voltage, and the polarization. It takes DC 3 volts, center negative. So I've got my bench power supply running. That's what you can hear. This tape just has some random audio of me being stupid, working on the last cassette deck I fixed. And if we press play, yay, this thing has an LED, which actually works right. Awesome. And so, yeah, it works. Rewind is kind of sketchy, the belt's slipping. So, even though this thing had very crusty old batteries in there, and we'll probably need to replace the terminals, it is basically working. It makes me very happy. And I'm sure that'll make my sister happy. Yeah. Okay. Anyhow, now to getting those belts out of there. Okay, I've got the cover positioned here so not to stress the leads. Iron is warmed up. Take the white off of SP positive, the black off of SP negative. And that is that. Now, fortunately, even though this is a little Walkman style thingamabob, it is very easy to get to these belts. What I like to do on these guys is first to take a picture so I can see how they're routed. I'll label them like belt 1, belt 2. I'll draw a picture too. And I'll just draw a basic outline of how it goes on there. It doesn't need to be a fantastic drawing. So we have the motor here. Its outline kind of goes like this. Flywheel here. And another wheel here. So we have this guy. Oops. My drawing's getting a little sloppy. We can't see B2 there, so I'll dash that. and it goes around the outside of this pulley like this. I'll call that B2. Make a table down here. Take off B1. Chop it in two. And measure the length. Now when you go to look up belts, they usually, will say like inside diameter, outside diameter, and these belts are usually between 0.5 millimeter and 1 millimeter in cross section. So it's not going to make any difference whatsoever on an old stretched belt by trying to get overly technical and call out the inner or outer diameter. So this is about, and I'm trying to hold it straight but not stretch it, it's about 148 millimeters. So I'll have to find a belt close to that. And we can also get belt 2 off of there like that. I'm wondering if there's a third belt for the counter. Some of them, there is another belt. And this one is, again, I'm not trying to stretch it, just hold it flat, about 122 millimeters. And my calipers are in inches, but we all know how to do math and convert from one to the other. That is about 1 millimeter in cross section, belt 2. And it's square. And belt 1 looks to be about the same. Yeah, it's about 33 thousandths, a little less than 1 millimeter. Okay, now we'll see if this does not have a counter. Okay, so it does not have a separate belt for the counter because it has no counter. Problem solved. GE mini recorder. I have a text document. I keep a list of all the belts in for future reference. I don't see. Nope, I don't see a. Oh, here we go. Model 3-5353B. Yep, it says power source 2 AA size alkaline batteries or 5-173 rechargeable pack. I think these contacts here are for the rechargeable pack. Now I want to try to get this small board out of this end to see what may have been done by battery corrosion. Okay, that kind of comes out of there like that. This switch is the pause switch. It's kind of loosey-goosey in there. It kind of sets on a little cradle. And this piece of plastic, this holder, is connected. Oh, that's heat staked on there. That's unfortunate. There is one screw, but there's a couple heat stakes. I don't know what that is. Maybe motor speed control, that could be. Because we get power coming off this board and power switch and red and black, yeah, motor. Okay, I think this is the motor speed control. The good thing is there is no corrosion evident on this board or the back of it. But the battery terminals are quite corroded. But I may be able to slip these out and then desolder them and soak them in some citric acid. We'll see how they come up. I think to try to pop those out, I'm going to grab this inner loop here, pull up a bit. Yeah, okay. First, I'm going to take some photos so I know how it goes back together. Got that one out, and actually that battery terminal looks okay. This one is quite crusty though. Oh, that one popped right out of there. Yep, okay. And this battery terminal's not too bad. This one's quite crusty though. I found having a pair of reading glasses with just the right magnification makes soldering larger stuff like this so much nicer. Trying to see if we could pop this whole mechanism out for cleaning. I don't see how it is fastened in there. Right there's where that little spring thing I accidentally took loose goes. We've got, okay, this piece of plastic is part of the mechanism. There's no more screws through here. Got a couple circuit board screws, but those go to metal parts. Got one screw there, which might hold it down. Last screw, I hope, for taking it out of the case. Perhaps, yeah, there we go. Yeah, I noticed there's a little moisture in here. Perhaps, yeah, right here. You see that glisten on the camera? It's perhaps from the batteries. But now we've got all this out of here. We can look at the gears. They look great. There's still some grease in there. We can get all this cleaned up. Clean the heads and the rollers and things like that. Yeah, it does actually have an erase head, not just a permanent magnet. No, that is a permanent magnet in a fancy case. Yep, there's no wires running to it. Oh, where did that come from? Ruh-roh. Mystery bracket. Okay, now we're down to cleaning, I think. I have our battery contacts and some citric acid here. This is about a 40% mix, so it'll do its magic relatively quickly. And I got the case parts all cleaned up, so the next step will be cleaning up the actual mechanism. Trying not to damage the red and yellow stickers on there, which my dad put on. I try to get the nooks and crannies of these other buttons here. I always like cleaning the pinch roller with some soap and water. I think this is Formula 409. A few types of rubber, and it's usually what's used in material feeding applications, like paper feed rollers and printers and copiers and such. They react poorly to alcohol. So I always try to keep alcohol away from them if I can. Most rubber, though, alcohol won't bother it a bit. I guess my dad had this cassette deck rigged up to some type of musical Christmas ornament. And my sister realized it was no longer working when she got the ornament out to display this year. So I'll try to pop a picture in here of what that is. Okay, well, this really wasn't very dirty inside at all. When putting this back together, I figured out where this unknown little bracket came from. This is actually just a standoff. There's no mounting post under there because that's where the buttons are. So if you have one of these, you don't actually need to take this guy out. Just want to let you know that's where it went. Okay, let's see what these guys look like. Here is the worst one. Oop, I dropped it. Yeah, that was the worst one. And it actually looks surprisingly okay. There you go. I would have guessed that thing was a goner, but it cleaned up really nicely. So I'm going to go flush all of these with water, and we'll let them dry and get them reinstalled. Okay, we're going to go through the same process for this little Radio Shack computer cassette recorder. This thing has a lot of bells and whistles. Got to get in here and have a look at the belts. All 4 of these screws are the same. Okay. I've got this one little oddball right here. Yep, okay. It seems to be holding things together. Sometimes an odd screw like that can be a sign that it's holding something else on inside. Something that doesn't necessarily need to come loose to get the thing apart. But that one did. Okay. There we go. Well, that came apart cleanly, didn't it? Yeah. Those rubber feet poke through there. Interesting. It's really hard though. It's not like a soft rubber. Got some foam pieces in here, but that's in good shape. It's not crumbling. Yeah. Oh, yeah, that belt is really floppy. You can see it's got kinks in it. And there's a piece of another belt here. I'm going to rotate this around. Yeah, okay. There is another belt that is below this one, and it runs up this way. It's a little more difficult when the belt isn't on there. Got a little tiny screw, and a lock washer, and a little metal brackety thing there. And our circuit board. Oh yeah, with the good old 1980s flux put on with a spatula. Lots of wires everywhere. There is a fiber washer right there. This is a little bit of a different construction than what I've seen before. Got a little twisty tie deal here. Got another little screw in this corner. Okay, a little wire holder there. Looks like those wires are loose. A little machine screw. Oh, there is another screw right there. I blend right in. Yeah, okay. Okay, this is a cap that's tacked on here. And there is this wire, which is the ground wire from the battery compartment. That is tacked on here. That's kind of glued in across the bottom. By desoldering a few wires from the battery compartment to the board. I was able to rotate the board around and expose the mechanism. So here's the main drive belt from the motor. It's loose and floppy. That's no big deal. This is a fixed idler. And there is no other form of tensioner, so that's not a big deal. So I made a crude drawing. I'm not an artist, but it gets the point across. The exact routing of what I call belt 2 here, I'm not sure of. But it's intact. This is belt 3 for the counter. That's also not a big deal because it's intact. And belt 2 has turned to goo, which is problematic. It went to the bottom of the flywheel here. This thing and this thing. So I'm not quite sure how it was routed on there. And the only way you can really get these gooey belts off is to carefully scrape them off there. And this goo gets everywhere, all over your fingers. And then it takes a lot of alcohol and Q-tips to get all of that goo out of the pulleys. Okay, I've got a couple of the pulleys cleaned up. I thought I'd show you the last one. Now, this one was held on by a split washer. So it's a little plastic washer. Imagine it's shaped like this, and it's split. And so when it slides on the shaft, it kind of distorts, opens up, and when it gets to the slot in the shaft, it snaps in place like that. This one and the flywheel were both held on with those. Sometimes they can be a little tricky to remove, but generally you can remove them and reinstall them without a problem. And this is probably the worst of all 3 pulleys, so I'm glad I could remove it. So I try to scrape as much of this stuff off of here as possible. If this was just a simple pulley, I would soak it in some alcohol, but it's some sort of spring-loaded thing, and it looks like it might have a friction pad or something inside. Some type of clutch, I think. So I've got some alcohol and a Q-tip here. Just going to go around like this. Get off everything I can that the Q-tip is reaching right now. Then we'll take the screwdriver again and try to get into the slot. And you've got to be very, very careful and get every bit of that goo out of there, or it'll get on the new belt and ruin it and cause it to fly off and break things, and you'll be unhappy, etc., etc. Got the pulley clean. It just pops back on the shaft like that. Yep, I can just feel the lip in it. I'll get the little lock washer like that. Try to get it centered, and I'll hold it on one side with my finger. There we go. I was trying to rotate it this way to open it up and then push it down to get it to snap into place. Okay, luckily somebody scanned the service manual and it is online, and it had a picture of this belt routing, which was like this. And this is kind of a tricky part right here because you need to get enough tension but not too much. So I'm kind of pulling the belt on here like this. You can see this is going to kind of be loose. That might be a little closer. So this end of the belt is the length I need to measure. I'll measure it here off camera. It is about 140 millimeters. That's the second time I measured it. I got about the same measurement. So we'll have to see what the closest measurement to that is. That is a little bit less because I'm sure that was a loose measurement. In the service manual, they don't call out the length. Now I need to connect this flywheel, but I goofed up a bit on taking that off of there. Okay. See if I can show you here. You notice it's got this one little peg here, but this one's missing. I was trying to pry that split washer off of there, and I accidentally got against this guy and snapped him off. Let's see, he sits like that. And this is just it's an alignment peg that these holes on the cassette set over. So it's on a piece of plastic that kind of sits in that hole and pushes forward. The mounts were quite brittle, but I think I can probably get in there with some super glue and glue it back in place. I'll take the cover here off to do that, but I'll get the pulley on first. So let's pick out our belts. I'll put a link to the company I get the belts from below, or the company that makes them and the company I order them from. The brand name on these belts is PRB. There's different ones that you can get in different parts of the world. Once you figure out their numbering system here, it's not too difficult. So our first belt on the second recorder we looked at was 217 millimeters long, which comes out to 8.543 inches. It was about a millimeter square. So this company does use inches, so if that offends you, well, maybe go someplace else. Actually, you know, either measurement system will work. Okay, so if we look down here for something about 8.5 inches, that's what this number here is. We have 8.2 and 8.6. So 8.6 is going to be too long because 8.5 was loose. And if we look at the next size up in cross section, which is the SCX, we have 8.4, but it has a much thicker cross section. It will probably still work. So that gives us a choice at 8.4, or the SCY is 8.2 and 8.6. So I'm kind of on the fence there as to which would be better to buy. So I'll write SCY 8.2 or SCX 8.4. So in trying to decide whether to go with the 8.2 or 8.4 inch belt, we can look at this measured length of 217 millimeters, which was pretty loose. And if we knock that down to 95% of the measured length, we get about 206 millimeters. Convert that into the superior inch system, and we've got about 8.1 inches. That sounds a little more reasonable to me, so I'm going to go with the 8.2. The cross section is also closer, and I'll do the same thing with all the belts, and I'll specify the correct one, and I'll get those ordered. I have some extra belts. I probably don't have all of these, but I'll see what I've got and then order what I don't. Okay, we got some belts in, so let's go ahead and get our cassette decks finished up. We'll start with the GE mini recorder. I've still got my map where the belts go, and I think we can slip both of these on without taking it back apart. While I was waiting for the belts, I did squirt a little bit of contact cleaner down in the mode switch. The switch presses down when you're in record mode. It doesn't take much, and this one, fortunately, the switch is spring-loaded. Some of them, the switch gets moved both directions by the play-record mechanism, and they're a little trickier. I'm doing a voiceover here because the audio quality got so bad. I apologize. I'm using a spring hook tool here to slip the new belts on. Even though this is a compact cassette player, it was actually very easy to put the belts on. Now we'll go ahead and solder the speaker wires back in place. Luckily the board was labeled and I had made some notes about this. Box of power adapters. Sure that I would not find a 3-volt power adapter, and I actually found one, and it happens to be center negative, and it's GE branded, so it matches the recorder. I have no idea where this came from. I'm sure it wasn't originally with this. And here I was demonstrating that the little tape deck now worked, but more sound problems, and it didn't actually pick up any sound. So I apologize. It does work just fine. Then I did the same basic process with the CCR-82. I used the spring hook on my fingers to thread the new belts on there. The little belt that went under the flywheel was kind of difficult to get in place, but got there in the end. Okay, I replaced the masking tape that was on here holding the wires down with some Cap-Tan tape. I put the little wire tie back in here that was holding all these wires out of the way. Soldered the battery compartment wires on. There's a black wire which went here, red wire which went here. I took some pictures of that. Now this guy goes right here. So we've got the power supply hooked up, and the thing I noticed, it is starting and stopping when it shouldn't be. And remember those 3 little micro switches on this board? This is the play button. It pushes this lever in right here, which hits this micro switch. And if I push it in, just put the slightest amount of pressure on it, it'll go. So one possible fix might be to slide the whole board that way. I can see the switch contacts right through there. So shut the power supply off. I'm just using a straight pin to kind of bend the fixed contact like this a little bit. And we'll press play. Yep, that is all it took. Just a little tweaking. Fortunately, they've got holes. This switch is accessible, and these two have holes. So you can kind of tweak them. Now I'm going to hit rewind. Okay, that one's fine. Stop and fast forward. Alright, that one's okay. So now we can try playing a tape. Make sure that guy's lined up again. And all our wires routed properly. Okay, so test again, that's fine. Alright. Eject. Put in our test tape. That little pin I glued on there works. Fast forward. Yep. Stop, rewind. Stop, play. The counter is countering. Don't hear any speaker noises. Just scratching. That could be the play record switch is not being nice. Okay, that's working. We're not past the leader yet. It's not turning on the record light, which makes me think that that record button is not in the correct position. So have a look at that. I was getting the same result with an external speaker. I took it back apart and I noticed a quite unhappy looking capacitor here. It is a 10 volt 1000 microfarad, so I'm going to zip that out of there and test it. So I can't get the reflection off there. There's the result of the capacitor testing, 27 ohms ESR, so it is definitely not good. I'll replace it. Well, we didn't have so much luck with this CCR-82. I kind of messed around and checked a few things. It seemed like I was getting no output out of the audio amplifier chip here. So I checked the input from the tape head. There didn't seem to be any input. The manual for the CCR-82 had the block diagram of the chip in there. So there's a pre-input, which comes directly from the tape head. There's an output of that, which goes into the power amplifier input. There was, I don't have any equipment that can measure the tape head directly, but, you know, rubbing my finger over the tape head input, which would normally cause a little popping and stuff, that didn't do anything. And there was no output here at all. There's a little spike when, you know, power was applied, but nothing really at all. In the data sheet for this particular chip, it showed the input impedance for both the power input section and the preamp section as about 20K. So I measured pin 14 to ground. That's open. The power input, however, was about 20K. I compared that to the Miniset 9, which we refurbished back in May. It uses this same setup here, the same IC, and indeed the preamp input was 20K. And you can see I bodged in a cap here. I didn't have a radio cap for that. That was the proper specifications, 1000 microfarad, I think, 10 volts. And that got me wondering if what might have killed this IC was an over voltage, because this is like a bulk filter capacitor type thing for the input here. And if somebody plugged in a 12 volt or something like that, this is a pretty low voltage cap, and it might have popped. The absolute maximum voltage on this chip is 12 volts. So depending on the power adapter used, they could have easily blown up that chip. The other, IC used to control the motor current, which is this guy right, or the motor speed, this guy right here, that actually works. The motor runs just fine. I found these on AliExpress, and I've got some ordered, but that's going to take a month to get here. But I think that will probably fix it up. And I just, at this time need to go ahead and button this up and move on to other repairs. But I will get the chips in and get the correct capacitor in here, and we'll get this thing fixed up. Well, how about that? We got 50% of the cassette decks working. The one that looked the worst because of the battery corrosion, this little GE unit here that belonged to my dad, that really was no problem at all. Just clean it up and put a couple belts on it, and it was fine. Even managed to find a GE branded power adapter for it to replace this dilapidated old thing. So I can get this sent back to my sister and she can use it on the Christmas ornament even this year. The little GE deck made its way back to my sister. She's got it plugged in and working and making the ornament musical once again. This little Radio Shack unit, which is a neat little cassette deck for computer use, it looked fine, but it had some problems inside. Bad amplifier IC, so we weren't able to fix that at this time, but it does have a new set of belts. So for now, we'll close this video out. If you have any questions or comments, I would love to hear from you. Just leave them in that comment section down there below. Thanks to everyone who helped support the Hey Birt channel through Patreon and other means. It's greatly appreciated. And until next time, bye.